Okay, so today is the day you hate me. We're going to talk about using matrices to solve systems, okay? So let's kind of look at the big picture here. So consider using real numbers. If I wanted to cancel out 3, would you agree that one way I could do that would be to multiply 3 by 1/3? Okay, and if I do that, I get 1. 1/3 is what we call the multiplicative the multiplicative inverse of 3. Because when I multiply that by 3, it cancels it out. It gives us 1. Okay? And 1 is our identity in real numbers. So, the same thing happens in matrices. Every matrix A has an inverse matrix, A inverse, that cancels it out. It gives us the identity matrix, that one I showed you with the 1s down the diagonal. Okay? The identity acts like the 1 in matrices. It's how we cancel stuff out. Okay? So, if I had the equation 3x equals 9, would you agree that one way I could solve this is to multiply both sides by 1/3? Yes. Okay? I'm going to squeeze it in over here on the left because if you'll remember from a couple days ago, matrix multiplication is not commutative, right? If I multiply something on the left, I have to multiply it on the other side on the left too. So 1/3 times 3 cancels out, and I'm left with x equals 1/3 times 9, x equals 3. All right, so let's look at this system, this equation. Matrix A times matrix X gives us matrix B, but I want to solve for matrix X. Okay? What I could do is cancel out A by multiplying both sides by A inverse. And remember, if you do it on the left on one side, you have to do it on the left on the other. So this gives me A inverse times A times matrix X equals A inverse times B. What happens with A inverse and A? Okay, so I get matrix X equals A inverse times B. That's going to be the setup and the process that we used every time we want to solve for a variable matrix.
So that's the answer?
That's how we find it.
Okay.
Yeah, this is just kind of modeling what we're going to do. All right, so here's a matrix equation. Matrix A times matrix X equals matrix B. Matrix A is what we call the coefficient matrix, and that will make more sense in a little while. Matrix X is what we call the variable matrix. And matrix B is our constant matrix. So, when we solve equations, we're solving for variables. So our goal here is to solve for our matrix, our variable matrix. So, kind of like what we just did, if I want to solve this, I multiply both sides by A inverse. These cancel, so every single time my variable matrix is equal to the inverse of my coefficient matrix times my constant matrix. Inverse matrices is an operation that you can do to a matrix. You can find a matrix's inverse. We're not going to do that by hand. We're going to let our calculator find the inverse for us. Okay? All right. So let's look at a matrix equation. Here's a matrix equation written out for us. So, this is matrix A times matrix X equals matrix B. I want to solve for X and Y. I want to solve for my variable matrix. So, what do I do to both sides?
Multiply my inverse of A.
Yeah, multiply by A inverse. So I get X equals A inverse times B. So let's write that out in matrices. I get the matrix XY equals, here's matrix A. To write the inverse of that, you put a little -1 to the top right corner times matrix B. Okay? All right. Let's see how we put this in our calculator. So, open up your calculator. Look on the left-hand column and find the X inverse button. See it?
Yeah.
Right on top of that, it says matrix. You see that? Okay. So press second matrix. Okay? And we want to edit the matrix. We need to put our own values in. Okay? So arrow over twice over to edit. Okay? And we want to put information into matrix A. So choose matrix A. What are the dimensions of our matrix A? 2 by 2. So enter in your dimensions. You just press 2, enter, 2, enter. If it's already a 2 by 2, you can just press enter and move your way through. Okay? And then you fill in each spot. Okay? So we would fill in 3. And you press enter after each term. So 3, 2, 4, 3. So here's matrix A. Okay? Now we've got to enter in matrix B. So we do that exact same process again. Second matrix, arrow over to edit, and we want to edit matrix B. What are the dimensions of matrix B? A 2 by 1. Now, let's say you accidentally thought it might be a 1 by 2. Look what your calculator does when you write a 1 by 2. Do you see how it rearranges it for you? Okay? So that looks different than the one we wrote down, right? So that makes us say, oops, no, I actually meant a 2 by 1. So I'm going to change it back to 2 by 1. And go ahead and enter in your two terms. Let's see, -5 and -9. Okay? So now we have both our matrices entered. Go back to your home screen. To do that, do second quit, which is right next to second on mode, and it'll take you back to your home screen. Okay? Now we actually want to call up and actually find the inverse of A and multiply it by B. So we're going to go get the matrix. Second matrix. This time we're not going to edit it. We just want to get it. So choose matrix A. Okay, but we don't just want A, we want A inverse, right? So find your inverse button again and type in your inverse. So that's A inverse. And we want to multiply A inverse by what? By B. So
Where's the inverse button?
it's right where the matrix button is.
Okay.
Same button. Okay, so second matrix, now get matrix B. Everyone here? And press enter.
Oh, wow. Oh, that's cool.
That's your solution.
What's with the brackets?
Okay? The brackets are because once our answer matrix is bigger, it's going to separate each term so it's clear what goes with what. The different operating systems do it differently, so don't worry about it. It's okay. So the matrix XY is equal to 3, -7. Okay? All right, let's do it again. You'll get so much faster at it. All right, copy down this matrix. No groaning about the fractions because you have a calculator in your hand. Not. All right, so this is matrix A times matrix X equals matrix B. I want to solve for matrix X. So I'm going to do A inverse times B. So matrix X is XY equals 5, 6, negative 7, 6, negative 1/3, and 2/3 inverse times matrix B. Yep. All right. So we're going to enter it in exactly the same way. So we have to go edit our matrices. So second matrix, arrow over to edit. Is it still a 2 by 2? Okay. Now, to enter in those fractions, use your division sign. So 5 divided by 6. When you press enter, it's going to look like it changed it to a decimal. But really, it stored your fraction. Okay, it's all there. It hasn't rounded. It hasn't messed up what you've done. Okay? So go ahead and enter in all your entries. Then let's go edit matrix B. Still a 2 by 1. And we've got 11, 1. All right, now here's something cool. When you go back to your home screen, if the last thing you entered was A inverse B, you can use second enter to recreate that last line, so you don't have to call it up again. And then just press enter, and there's your solution. Okay? If you didn't get this, that means you accidentally typed in something incorrectly. So that's the only downside to using your calculator, right? Is that it's really, really easy to misclick something, and it messes up your whole problem. So make sure you're checking and going back. If
you mess something up, will it be obvious? Like, it'll be like a big decimal, or it could just...
Not necessarily. All right. Let's work on actually turning a system into a matrix equation. All right. So this is a system that I could very, very easily put on a non-calculator part of a test and ask you to solve. Okay? 2 variables. Straightforward values, no problem. We can use elimination here, we can use substitution. You know how to solve this by hand. Okay? If you don't have to solve it by hand, though, it's fine to use matrices. But don't forget everything you've learned. You still have to remember elimination, substitution. Now you have an additional great way to check your work when you do something by hand. Okay? Really?
What happened?
All right. Here we go. Matrix A times matrix X is equal to matrix B. Okay, what did I tell you the name for matrix A was? The coefficient matrix. Okay, so where we get the values for matrix A comes from the coefficients of your variables. So, 4, 5, what's the coefficient of negative X? Negative 1, and what's the coefficient of Y? 1.
So you have to get them in like X.
Yeah, so in order to set up a matrix equation, your systems must be lined up in their columns. X, Y equals constant. Okay? Or X, Y, Z equals constant. Or A, B, C, D equals constant. Whatever that case might be. Okay? So 4, 5, negative 1, and 1. Everyone see where I got these numbers?
Yes.
Okay? Matrix X is my variable matrix. What are my variables?
X and Y.
Okay? You've got to go from left to right.
You have like X, Y, and Z. Do you put that in there too?
Yep, and it would still go left to right, so top to bottom. Okay? All right? B B is our constant matrix. What are our constants?
-3.
And 3. Okay? All right. So to solve for xy, I want A inverse times B. Can you do it?
Yeah.
Go for it.
I got it.
Let me know if you're getting stuck on your calculator. Okay, yeah. Okay, what'd you get? Good. So, our matrix XY, guys, there's too much chatting going on, is -2, 1. But this is a system, and I write a solution to a system as an ordered pair. So my solution is my ordered pair, -2, 1. Okay. Think about matrix multiplication for a second. Okay, you don't have to write this down. I just want to show you something. Notice that if I were to multiply A times X, first of all, A is a 2 by 2 and X is a 2 by 1. Am I allowed to multiply those?
Yes.
Yes. And my solution is going to be a 2 by 1. All right, let's think about how we do it. Remember, it's row by column. So for the top row, first column, I would do 4 times X plus 5 times Y. See that? And then you do -1 times X plus 1 times Y. Doesn't that look exactly like our system? Okay? That's why this works. That's why separating it in this way works, because of how weird matrix multiplication is. Okay? All right. Use abbreviations to jot this down as quick as possible. French roast coffee costs $5.20 per pound. Colombian coffee costs $4 per pound. How much of each kind should be used in a 100-pound mixture that costs $4.72 per pound? And there should be a question mark there. Okay. In an application problem, that's really the reason we do systems, is because we can solve great application problems with them. These systems really do come into use in the real world. Okay? So, this is a problem you'll see a lot. This is a mixture problem. So we're combining two different things to create a mixture. Anytime you have an application problem, though, don't forget you have to define your variables. So let's let x equal, what is our variable? What are our variables here?
The cost.
Okay, the cost is given to us. Pounds of French roast and pounds of Colombian. That's what we're looking for. It says how much of each. So let's let x be pounds French roast and y be pounds Colombian. Okay. How many variables do we have? Two. So how many equations do we need? Two. All right. Let's start with an easy one. We need 100 pounds. Good. Everyone okay with that one?
Yes.
Okay. Now the little bit more challenging one. we got to deal with all the costs. Okay? The French roast is $5.20 per pound. So would you agree that that's 5.2 times X? So $5.20 times however many pounds we have, plus $4 times however many pounds of Colombian we have, equals
100 divided by 472.
Okay, let's think. It's cost times amount plus cost times amount equals 472 times 100 pounds. Cost times amount. Do you guys see that? That's the tricky part in this, is remembering that, okay? We have cost times amount plus cost times amount. It has to equal cost times amount, okay? So, do you see how this is set up perfectly for matrices?
Yes.
We get our coefficients, we get our solution, we type it in. Are you guys okay if we don't continue and put this in our calculator?
Yes.
Okay? That's okay. Yeah.
Okay, so if you're like doing this and then you have the other equation on top.
That's okay.
Okay.
What's important is that your variables are labeled, and then everything's going to work out the same way. Okay? So when you solve this, guys, you're going to get 60, 40. Okay? But you can't just give me 60, comma 40 as your answer. You've got to tell me 60 pounds French roast, 40 pounds Colombian. Your units are graded on application problems because I've got to know that you know what you found. Okay? All right. Let's look at a little bit bigger matrix system that we're going to use a little bit bigger matrix for. So go ahead and copy this down.
If you just have like 60 LB equals X, would that be wrong?
Because you got to tell me pounds of what. All right. 3 variables means I must have 3 equations. Okay? Which I have. Now, remember I told you that in order to do matrices, you had to line up your variables, right?
Yeah.
So before we can enter this into a matrix and solve it, we've got to get everything lined up. Do I have to change anything about my first equation?
No.
Okay. All right. What do you notice in my second equation?
There's no y.
There's no y. Okay. When you enter into a matrix, your coefficients, every single spot must be filled. So if we don't have any y, exactly, we're going to put a 0y. Because when you enter into a matrix, you can't just skip a spot. Everything has to be filled. So you have to use zeros as your place fillers. All right?
Should you use a matrix for anything?
Yeah. Okay. What are we missing here?
We're missing a x.
All right, so 0x, then what?
Minus y
Minus y
plus z.
plus g equals 3. All right? Okay, what's the only thing that changes when you enter this in your calculator?
That there's going to be a bigger
It becomes a 3 by 3. So go ahead and quickly do this. Flag me down if you're having trouble with your calculator. Okay, write out your coefficient. Okay, yeah, I think a lot of people are shut. We'll come back over here. Okay. All right, so I let you loose a little too soon. Let's write this coefficient matrix. So Our variables are
1.
x, y, z, correct?
Yes.
That's going to be equal to our coefficient matrix, so let's write that out. What's the top row?
Top row is 1, 1, 1.
Okay, the second row is going to be 2, 0, 1. And the bottom row is going to be
-1.
0, -1, 1. Inverse of that times my solution matrix. So what's that going to be? 0, 12, 3. Does that help those of you that were a little confused on starting? Okay. So I'm going to give you another second or two to enter that in, and then we're going to move on.
I like this.
I'm glad you like it.
So, are we allowed to use calculators in the next test for this?
So the test, guys, will have still a non-calculator portion similar to your quiz. You've still got to know how to solve some by hand, okay? But the majority of the test will be applications and bigger systems that you would use your calculator for. Okay, what'd you get?
7, -5, -2.
Good. 7, -5, -2, but how do you write your answer?
You write like a parentheses and you
Good.
equal it to x.
7, -5, -2.
On that, to show that it's x, y, z, you would have to...
Nope, I know because of the order it's in.
Oh, okay.
Okay. Shh, 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 shh. Guys, your chatting's really slowing us down.
Elaine turns around and she likes
Okay, use some abbreviations and jot this down. You can use N for nickels, D for dimes, and Q for quarters. Julie has $4.20 in nickels, dimes, and quarters. She has 44 coins in total. The number of nickels is one more than twice the number of dimes. How many of each coin does she have? All right. So, how many variables do we have?
3.
3. So, how many equations do we need?
3.
Okay. Let's do the easy one first. There's 44 coins total. You could, of course, use X, Y, and Z. That's fine. I just want to keep myself a little more organized. Not more organized. It's just, I should put it, it's easier for me to stay organized this way. Okay? All right. How about $4.20 in nickels, dimes, and quarters? Do y'all see where those numbers come from?
Yes.
Okay. The number of nickels is one more than twice the number of dimes. So I see number of nickels is. That tells me this is going to be N equals one more than twice the number of dimes. 2D plus 1. Good. All right. What do we have to do before we can use a matrix to solve this? Yeah, we got to line it up. What's the only equation we need to rearrange, though? The bottom one. So I'm just going to rewrite the bottom one, if that's okay with you guys. All right. Let's line it up. What's going to be in the N column?
Negative N. No, N.
Just N
Minus 2D.
minus 2D
Plus 0Q.
plus 0Q equals 1. You guys okay with that?
Yes.
Okay. Then notice where our coefficients come from. 1, 1, 1, 0.05, 0.1, 0.25. Be really careful with this decimal. Very often on quizzes and tests, people tell me that a nickel is worth 50 cents because they forget that 0. Okay? It's a frustrating mistake to make. All right? Are you confident that you could put this in your calculator and get it?
Yes.
All right. I want you to glance real quickly with me at number 3 on your homework. I want you to glance at number 3 on your homework. This is a challenging problem to set up, and I want to talk about it. Okay, not everything on your homework It's not like it's a matrix homework. You have to use matrices. It's application problems that now you have a great tool to solve them. So yes, most of them you will probably use matrices. I believe most things from now on, unless I make you do it by hand, you're going to use matrices, and that is fine by me. But we got to talk about some things. So number 3, read it on your sheet, okay, because I left out an important sentence. Your sister walks to the movies at 5 miles per hour. 10 minutes later, you leave on your bike at 15 miles per hour. You reach the movie theater at the same time. How far is the theater and how long did it take you? Okay, you're going to see these problems come up a lot. The equation that we're going to use every time for these problems is distance equals rate times time. Anytime we have a problem with distance and rate, we're going to use distance equals rate times time. Now, the tricky thing is we have to decide what time we're talking about. So it's saying, how long did it take you? So I'm going to let t equal, I'm going to call it my time because it's saying you. I'm going to let t equal my time. Then, for my sister's time, it's going to be in terms of my time. Okay? So let's write the easy equation first. Let's write my equation first. So distance equals, what's my rate?
15.
My rate is 15. And my time, would you agree I said that my time was t?
Yes.
So d equals 15t. That's my equation. Okay? Now I've got to write my sister's equation. So again, it's d equals, what's her speed? 5. As soon as you write down that 5 for the second equation, you need parentheses because we've got to manipulate t to represent her time. Okay? All right. Was she walking for longer than I was, or shorter? Longer, because she was walking for 10 more minutes, right? So as soon as you decide longer versus shorter, when it's longer, you're going to put t plus. If it's shorter, you're going to put t minus. Okay? But I can't put 10 here because my speed is in miles per hour. So 10 minutes equals how much of an hour? 1/6 of an hour. So instead of doing t plus 10, I do t plus 1/6. Okay? The two tricky parts, remembering your parentheses and remembering to convert the minutes to hours. Okay? So I wouldn't do a matrix for this personally because I think it's more work to get it set up. You have them both equal to d, so what can you do? Just set them equal to each other and solve for t. Okay?
Do you have to solve for R?
No, you're given the two rates, 5 miles per hour and 15 miles per hour.
Okay.
Okay? Yeah.
Why is the 1/6 where it is? Like, why is it inside parentheses?
Because t plus 1/6 is all the time of my sister's. Because of us, it's my time plus 1/6 of an hour, and her whole time has to be multiplied by 5. Okay? All right. So remember, this homework is not due necessarily tomorrow, but you can work on it